Okay, so we're going to talk about horizontal stretches and compressions from a table perspective. So here you are given a table, and we need to create a new table for g of x. So our table is going to have x, and it's going to have g of x, and we need to figure out if we're given from this table, what would our new table look like? All right, so we have to look at the function says f of 1/2 x, which means what we are trying to figure out, what do I multiply by to get back to f of x? Okay, so you're going to take the reciprocal of the b value. And in this case, our b value is 1/2. So our b value, so 1 over b is the same thing as the reciprocal. So our reciprocal in this case is 2. So we are going to multiply my x values, inputs, by 2. Okay. Then once you've identified that, then you can identify that that is either a stretch or compression. So a number, so 1 over b is bigger than 1, right? In which case our 1 over b is 2. Then it's going to end up being a stretch. Okay. And so we have a horizontal stretch. Okay, so let's take a look at what that means. That means I'm going to have all my y values stay the same, but all of my x values are being multiplied by 2. So that means my new x values are going to be 4, 8, 12, and 16. All right, so now let's take a look at what's happening here with our square root function. So remember, your square root function looks like this. It's got a horizontally stretched by a factor of 3. So now we have to go backwards. Remember what we were trying to do? We were trying to say f of bx, you need to multiply to get to f of x, right? But now I am saying that we need to multiply by 3. So if I need to multiply by 3 to get to f of x, then wouldn't that indicate then that I've got now 1/3 of x? So that if I were to take 1/3 times 3, that's going to take me to f of x. So what that means now is I have the g of x is equal to, inside the radical, instead of x, I'm going to have 1/3 x. Okay.